All right, let's take a look at two examples where we are factoring quadratic trinomials using the diamond method. The first quadratic that we're going to be looking at is x squared plus 2x minus 24. To begin with, when you're factoring anything like a quadratic, you've got three terms. The very first term, the x squared term, that's your that's your quadratic term, and it's 1x squared. Okay, the middle term, this term here, that is your linear term, and then your constant at the very end, negative 24. That's the third term. Okay. When you're factoring a quadratic, the very first thing that you want to do is identify the coefficients that you'll be using. Okay, and if you think about the coefficient is really just your quantity, your number that's multiplying your term. Okay, so we have three coefficients each time we're looking at a quadratic. In this case, our quadratic term, our coefficient for that is a. And in this equation, in this expression, it's going to be 1. All right. Our middle term, the linear term, its coefficient is 2. So we call it B is that middle coefficient, and in this case, it's 2. C is our constant, and our constant is negative 24 in this one. Okay, and remember, you want to include the sign that goes with the term to the right. Once you have your coefficients laid out, then we can start by factoring. And to factor this particular quadratic, we're going to use something called the diamond method. Okay, and this is just a way of organizing that information that you can use when factoring. Okay, I drew a large X, and that's your diamond. At the top of the diamond, you are trying to find the number that you're going to factor for this problem. Okay, and to do that, you need to find factors that multiply. Okay, to the term A times C. Okay, the A coefficient times the C coefficient. Okay, in this case, because our A coefficient is 1, 1 times a negative 24 gives us negative 24. Okay, and we're ultimately going to have to find two factors that multiply to give us negative 24. Okay, but they also have to satisfy another condition, and that's that those same two factors, they need to add to the linear coefficient B. Okay, so in this case, our linear coefficient is positive 2. Okay, so we need to find factors that when you multiply them together, you get negative 24. But when you add those two factors together, you get positive 2. Okay, so to do that, we can draw up a factor table, and I'm going to do this to the side. Okay, negative 24 is the term that we want to factor, and we can find factor pairs for it. Okay, there's an obvious factor pair, and that's your trivial pair. Negative 1 times the number itself, 24. Okay, and then we can continue finding other factors or other factor pairs. So negative 2 and 12 is another good pair. Negative 3 and 8 will get you negative 24 if you multiply those two together. And then negative 4 and 6 are also a good factor pair. Okay, because the term that we're trying to factor is negative, if it's a negative 24, there's going to be some additional options besides our 4 main factor pairs. Okay, and that's going to be each pair with simply the sign swapped. Okay, so another possibility is we could have negative 6 and positive 4. Could have negative 8 and positive 3. Could have negative 12 and positive 2. And then lastly, we could have negative 24 and positive 1. Okay. All right. So again, like I said, we are trying to find a factor pair that when you multiply them together give you a negative 24, but that when we add them up, we get a positive 2. Okay. The nice thing about your factor table is that you can create a column to the right of your factor table, and in that column you'll simply write what the sum of those two factor pairs is. Okay, so for our first factor pair, negative 1 plus 24, that gives us a sum of positive 23. For our second, negative 2 plus 12, we'll get a positive 10. Okay, and so on. Okay, now only, that should be a 23 here. Okay, now only one of those pairs is going to be the one that adds to a positive 2. Okay, so only one pair is really going to satisfy both multiplying to negative 24 and adding to positive 2. Okay, and if you notice your factor table, it tells you that those two factors are that specific pair, negative 4 and 6. Okay, so let's return to our diamond here. I'll put those two factors, negative 4 and 6, okay, on the left and the right side of the diamond. Okay, on the left and the right side, those symbolize your two binomials, the ultimate, the end result of factoring. Okay, and the sides of the diamond are made up of two components. Okay, so remember, any binomial always has a variable term and then a constant term. Okay, and so to get the variable term, we're going to take our coefficient a times our variable. In this case, that's x. Okay, so we know our coefficient for the variable term is 1. And we know that our variable, since that's x, will have 1x in both of our binomials. Okay, so now the left and the right side are completed, and we essentially have our two binomials, and we're just going to take those left and right side and we'll write them out slightly more appropriately as binomials. Okay, so when we factor it, our end result is going to be this one. In parentheses, on the left side, we've got 1x and then minus 4. Okay, and notice I used the sign on our factor, negative 4, as the operator. Okay, that's the operator between our two terms that are binomial. And we don't really have to think about what we should write there. We know that the sign really tells you what that operator is going to be. Okay, so we have 1x minus 4 times a 1x plus 6. Okay, and that is your factorization for that problem. All right, let's take a look at one more example, and we can use the diamond method to its fullest extent here. All right, in example 2, we're going to use that same diamond method to organize and factor this trinomial, x squared minus 13x plus 40. Okay, so again, I'm going to draw my diamond. Okay, we need to know what our coefficients are. A is positive 1. Okay, we assume that if it's not written otherwise. Okay, B is going to be negative 13. Okay, don't forget to include the sign with the term. And then your constant, that's a positive 40. Okay, so our constant's a positive 40. And we've got our three coefficients that we use to factor. Okay, remember in the top of the diamond, we have A times C. 1 times a positive 40 means that we're going to be trying to find factors of 40. Okay, in the bottom of your diamond, you know that those same two factors that multiply to 40, they have to add to the linear coefficient B. In this case, that's negative 13. Okay. This time we're going to see if we can omit the factor table, okay, to a great extent. And that's possible if you know immediately kind of what those factors are going to be that multiply to 40 yet add to a negative 13. Okay. And hopefully you noticed if they have to multiply to a positive number yet add to a negative number, the only way that that's going to happen is if both of our factors are negative to begin with. Okay. So if it adds to a negative number, those two factor pairs have to be negative. Okay. So if you went through and found your factor pairs, that's great. Okay. One of those is going to be your the only pair that satisfies both multiplying to 40, okay, and adding to a negative 13. Okay. And so in this case, our two factors are negative 5 and negative 8. Okay. They multiply to give you 40, and then they add together to give you a negative 13. Okay, so that is going to be the only factor pair that works here. Again, our variable term should be our a coefficient times the variable x. Okay, so we have 1x. Okay, and that's the same variable term for both binomials. Okay, so our left binomial here, we'll write this just below. 1x is our variable term. We know that negative 5 is our factor, or excuse me, our constant. So we've got 1x minus 5, and that's multiplied by our other binomial, 1x minus 8. Okay. Again, no worries on needing to know what operator you should use in your binomial. Okay. That sign on your factor term, that is always functions as your operator in your binomial. Okay, so we've got x minus 5 times x minus 8, and that's our factorization.